Hello, class. Today we're going to be talking about coterminal angles. Before we begin, just a couple things to keep in mind. Um, you guys know that the extension for the due date for the grading has been moved to April 5th, which means I have until next Sunday to wrap up the grades and put it in your marking period. There are several of you guys who have requested an email, and I gave it to you, and all I have to do is now in the process of grading it. But with all this video and notes and updating the Power School really just takes a lot of time. I know that I'll get to it ASAP. Just give me a little bit more time, and I'll get everything done. I promise you that. Um, with this week, we will have one more assessment, and I believe that's the last assessment for the marking period. If there's anything if there's anything that you guys need in terms of retakes or things like that, you guys have to let me know through email, and I'll grade it for you guys ASAP. We were planning to come back actually today before we actually started the remote training on March 30th. That was the original plan. However, at this rate, with President Trump extending our social distancing policy for 2 additional weeks until April 30th, I don't think it's going to happen anytime soon. So, most likely, if the situation gets a little bit better, the earliest we could meet, I believe it's somewhere in May. But don't be surprised if it extends until June. We never know. With that being said, all of the state testing, as you probably have heard, has been canceled. NJSLA is out of the question. And so, in terms of our curriculum, we'll be doing a lot more of this SOHCAHTOA stuff, coterminal angles and things like that. And we'll do our sine, cosine, tangent, cosecant, secant, and cotangents, trigonometric graphing, and those kind of things. And we'll get to the projects that we were all assigned to do before we started remote learning. You guys know your group members, you guys know your topic, and so we'll be talking about that for our something like math fair. It will build into that, but that's later down the future, maybe about a month later, so we don't have to worry about that now. But just keep that in mind if this plan ever happens. Okay, so coterminal angles we'll get started. Your quizzes are in the process of being graded, and that portion like reference angles and finding trigonometric values, I believe what's much more complicated than doing these coterminal angles. So we'll start with something light for you know the last week of March, and today is just Monday, right? So we're just barely breaking through this topic here. So let's do a quick review. Make sure that you guys all understand what reference angle is first. Please take a moment and pause the video now and then really try these two problems, okay? So pause the video for me now, please. Okay, now I'm assuming that you guys have already completed this. Let's go over how to do these questions. First, it says to draw each angle. So I'm going to draw the data, 210 degrees. 210 degrees means that I'm going to start at the 3 o'clock position. I'm going to go 180, and I'm going to go additional 30 degrees more. Okay, and now this right here, we call that the terminal side. Please understand what I mean by the terminal side. It's the side that where the angle actually meets up. So this is the entire angle 210, and then it ends up the terminal side at the third quadrant, which means ASTC, tangent is positive here. That's just a side note. Now, what's my reference angle? Well, the reference angle here is simply 30 because that's the reference angle that we find is always theta minus 180 degrees when we're talking about the third quadrant. So the reference angle is 210 minus 180, which gives you 30 degrees right there. Now, for the second one, we have the 5 pi over 4. That is pretty much the same thing because 4 pi over 4, the way I see it is 4 pi over 4 plus pi over 4. And I know that's just pi. That's 180 degrees. Looking at the radians, it might seem a little confusing at first because not a lot of us are used to it, but we just have to make sure we get also comfortable with that. So this right here is 4 pi over 4, and I go additional pi over 4 extra. So I know my terminal side ends on the third quadrant, and that is a reference angle of pi over 4. So again, if you're trying to think about the reference angle, it's always theta minus 180 degrees, or in this case, it's theta minus pi. So 5 pi over 4 minus 4 pi over 4 gives me just pi over 4. You can also think of it that way. Okay, so for today, we're going to be talking about coterminal angles. And this is the basic definition of it, but the way that I always think of it as you add slash subtract 2 pi or 360 degrees based upon what you're given. So if you're given degrees or radians, it really changes the context, right? What you really need to understand also for coterminal angle is that they share the same initial side and the terminal side. So what does that mean? Initial side, guys, it's always your 3 o'clock position, initial side. And your terminal side, like I said, is wherever the angle ends up. It could be here, it could be here, it could be there. It doesn't matter where it is. But if that is the angle, that's your terminal side. Okay? So we're talking about whether the angles share the same initial side and the same terminal side. So an example of that might look something like this. So imagine I give you something, let's say 60 degrees, where the initial side is here and the terminal side is right there. Well, the coterminal angle, therefore, if it's given in degrees, it says that it's going to add or subtract 360 degrees or 2 pi, depending on what you're given, right? So you're going to be adding or subtracting 360 degrees. So another angle might end up being is 420 degrees. So how would I be able to plot 420 degrees? Well, it turns out that if you start on the same initial side and you go round one full 360 and then go additional 60 degrees. So it might actually, I might just draw a little bit differently. One full circle and I go additional 60 degrees like that. So it's like a circle and then going up a little bit more. That entire circle from here to here is 360 and then you go additional 60 degrees more, which means it's 360 plus 60 gives you 420. Now, if you think about what happens, it ends up on the same terminal side as it would for the 60 degrees. So that's how you know that that's going to be your coterminal angle. Coterminal angle, like the name says, it co means to be together, or that's the Greek prefix for being like together, wholesome, that kind of thing. Cooperation, cooperate, that corporation. So it's more than just one, and you are sharing, you're together, the same terminal side. That's basically what this means, coterminal. Okay. If you go in the negative direction, I'm gonna mark that in green. That's 60 degrees, that's your terminal side right here. But if you go opposite direction, so for example, let's say 60 degrees minus 360, which gives you negative 300 degrees. The negative just simply means that I'm going in the opposite direction, like in terms of the clockwise, counterclockwise. We're going in the clockwise direction, and then this portion right here will end up being 300. Because this part right here is 60. So if you complete the full circle, that gives you 360 degrees. So negative 300 degrees is also another coterminal angle. It's like I said, plus and minus 360 degrees. So what if you were given in radians? What if you were given in 3 pi over 3? Well, it's plus and minus 2 pi. That's simply how this and this are translated between degrees to radians. Okay, so now that you know that, let's try some problems. It says to find one negative angle that is coterminal to 150. Well, I know that 150 degrees has a terminal side somewhere in the second quadrant. Now, do you have to do all this stuff? Well, you don't, but I would love to. I'm going to ask you to show me the drawing, and if I ever ask you to, you need to label where the terminal side is and where the initial side is. So you need to know where those things are. That's 150 degrees. Now, if we're talking about a negative coterminal angle, that means we simply have to subtract 360 because that's going to give you a negative number, right? 150 minus 360 should give you a negative 210 degrees. And if you were to plot that, you start on the same initial side, you go this much, that's negative 180. You go additional negative 30 because that right there should be 30 degrees. So that right there is negative 210 degrees. Notice how they both end up at the same terminal side. So I know for a fact that that is the correct one. So yes, if I ever ask you this question, you just tell me that's negative 210 degrees, I would really not like to see that. I really need to see this drawing as well. Okay, so draw, because Quite unfortunately, I can't see you guys understanding this, so you guys need to demonstrate it for me a little bit more and elaborate on your paper when you guys are working on this. Next question. Find a positive and negative angle. So they are asking you to find both. That is coterminal angle to pi over 6. Now, some of you guys are going, okay, Mr. Kim, all I got to do is just, oh, that's not it. All I got to do is just write 2 pi, and that's it, right? Well, technically, yeah, but just elaborate for me a little bit more. So you have to add pi over 6 plus 12 pi over 6, pi over 6 minus 12 pi over 6. You got to tell me 13 pi over 6 and negative 11 pi over 6. You got to be able to tell me that. Do not leave your answer in this format. This is no good. But also at the same time, I need you to show me your drawings, right? So on the xy coordinate plane, pi over 6 radians is simply 30 degrees. The same thing as saying 30. So I know it goes about this much. So that's your initial, and that's your terminal, and this is your angle, pi over 6. And now, how would I be able to find one positive coterminal angle? Well, that's this, right? That's your one positive coterminal angle. That's 1 full pi. That's 12 pi over 6. That's this much from here to here. But you go additional pi over 6, so that tells you it's 13 pi over 6. So this one checks out. Next one is going in the opposite direction. You're going about this much. Well, that's simply 2 pi over, well, that's 2 pi. That's 12 pi over 6 minus pi over 6, because this entire full circle is 12 pi over 6, but you're subtracting this much away to only go from, let me mark this in blue, to go from here to here. We're only looking at this sort of like a G, letter G part. And so that's negative 11 pi over 6 because you're going in the clockwise direction. Remember, counterclockwise is always a positive angle. Your angles is always measured in a counterclockwise direction. Okay, and then clockwise would just simply be negative. All right, so next question. Find one negative angle that is coterminal to 415. Find two positive angles that is to an angle that is 11 pi over 2 radians. I would like you to pause the video and try these questions. Try these two questions on your own. So pause the video now. Okay, so I'm assuming that you guys are done. One negative angle that is coterminal to 415, well, that means that I need to subtract 360, right? But if you subtract 360 from this, you get 55 degrees. It's still not negative, so you need to subtract 360 just one more time, and you will end up with negative 305 degrees. Or from the beginning, if you subtract 720, that should do the trick. Okay. Okay. Next. Oh, by the way, when I'm drawing this, 415 degrees is about this much, where you're adding 55 degrees to 360. But if I'm trying to look for one that's negative, that means I have to go in the opposite direction, this much. And so that is 360 minus 55, which gives you 305 degrees. But gotta make sure that it's in the clockwise direction, so it's negative 305 degrees. So you can also tell it to me that way. I know that the drawing part will be very arbitrary for some of you guys, but just do your best in showing me the process of that. Next question. Find two positive angles that are coterminal to an angle that is 11 pi over 2 radians. Now, if I'm talking about two positive angles, that means that I could add 2 pi over 2, right? But there could be many different answers for this. Because 11 pi over 2 radians, believe it or not, guys, it's a lot. 4 pi over 2 radians is 360. 8 pi over 2 is going to be 720. So that just shows you the 11 pi over 2 is a lot of degrees. So you could, if you wanted to, subtract 4 pi over 2, okay, and that will still give you a positive answer. So, you could do 7 pi over 2, and you could do, 3 pi over 2, because you can subtract another 4 pi over 2 from it, but that's pretty much it, right? But if you were to just go in the other direction and you just keep on adding 4 pi over 2 multiple times, so 15 pi over 2, 19 pi over 2, 23 pi over 2, and the list can go on and on and on, then they'll all end up being positive, and that's great. It's fine if you kept on writing it to me that way. Now, as long as you understand where the terminal side and the initial side, for the drawing aspect of it, guys, I would really like you guys to just write down where the initial side is and where the terminal side is. I think that's the only thing I'm really interested in you being able to do. So 11 pi over 2 means I need to keep on subtracting 4 pi over 2 to find out where the terminal side is. But you start from the initial side, so you're going to write down this as your initial. Ooh, I can't go any further than that, so this is your initial. That's 4 pi over 2, and that's 8 pi over 2. And then you go this much because that's additional 3 pi over 2 on top of the 8 pi over 2 that we have done with 2 cycles from here to here. Okay? So this one marked in red, I'm going to show you. That's 2 circles. That's 720 degrees. That's represented by 8 pi over 2. And then you go additional 3 pi over 2 because your total should be 11 pi over 2, right? So your terminal side will end up being at the negative y-axis, so that is your terminal side. Okay. Okay, and these 4 questions will be your review guide. I would like you to try these 4 problems on top of the assignment that I'm going to give you. So find 2 angles in a one clockwise and one in the counterclockwise direction. In total, you will have 8 problems. Basically, I gave you these odd problems to do, but you will have 4 more problems here that you will do. For this one, I'm just going to leave it blank because if I just give you the answers right away, then it really doesn't serve the purpose. From this point onwards, please assume that because of the NJSLA being canceled, a lot of your work will be very, very downgraded to being maybe just doing only a couple problems each day. Yes, you'll be learning, and I hope that you guys are doing the work, but please submit it on time and no Google Docs whatsoever. One of the new policies that I'm going to implement, and again, I am also a student of remote learning. Every teacher in the country is like this. The system's not going to be perfect, but the way that I always want you guys to encourage is to always geometry your work and work on a separate sheet of paper. And handwritten assignments is the only thing I'm going to accept from this point onwards. So take a picture, scan the documents, and submit it to me in that format. Nothing else is accepted. Okay, hopefully you guys are staying safe out there. Make sure you guys, wear masks, wear gloves. If you're planning to go outside, always remember to wash your hands and have hand sanitizers, in your, somewhere accessible in your house. Thank you and have a good day.